All right, good morning, everyone. Today is part 2 of week 5's lesson. Our objective is to compute values of future investments with continuously compounding interest rates. Okay, so let's talk about what that means. First, we're going to talk about the compound interest formula, and then we'll talk about the continuously compound interest formula. So before, we had this formula, F equals P times 1 plus R to the T, right? So this formula only works when we have the same units for when the rate increases or decreases and the amount of time, right? So if we have a monthly interest and we're measuring in months, then great. But we have this compound interest formula that can help us if we don't have the same units, right? So if we have an interest rate that's being compounded monthly and we only know our time in years, we can use this n value to help us. So what we're going to do is we're going to say t is always going to be years now, okay? So with this formula, it doesn't matter as long as t and r are using the same amount, the same unit, right? Okay. Now, same thing here with p. But we can use the same, this is still our initial value, so I mean the same thing, P and P are the same. So I guess I'm skipping around. So P is the same, F is the same for the old formula and the new formula. R is still the same. R is still my rate. But now, N is going to be the number of times the period goes into a year. So number of periods in a year. So if we have a rate that compounds every 6 months, then n would be 2 because 6 months goes into a year 2 times, right? So if my rate compounds every 6 months, then n is 2. So what do I mean by compound? That's how many times the interest is applied, right? So if I have a 3% interest and it's applied every month, that's a lot different than if my interest is applied every year. Okay. So that's one of our formulas. Our other new formula is the PERT formula, or continuous compound interest. Again, P is still the initial value, and R is still the rate. And T is always going to be in years. Again, okay? So everything we're doing with compound interest has years as our T value. Now, the new thing here with compound interest is this value E. E is called Euler's number, which is spelled E-U-L-E-R. Euler's number. And it's kind of like pi. It's a number that is always equal to the same thing. So E is always 2.71. Pi is always 3.14, okay? So Euler's number, we found out that this number is the maximum, is like what will maximize the amount of money you're getting per year, okay? So we're going to use Euler's number when we're computing our compound interest. So let me give you a couple of examples just to orient yourself, because I know this is a lot of formula right now. So this example is going to use all 3 formulas that we've already used, or that we've learned so far, okay? So a youth group has a yard sale to raise money for charity. They earn $800 and decide to put the money in the bank. So option 1, they can get a 3% interest rate compounded yearly. How much money would they have in the bank after 1 year? So what happens here is we can use our compound interest formula, and we get F equals P, my initial value, 1 plus the rate as a decimal would be 0.03 over number of periods in a year. So this is 1 year, so this is just over 1, and then I have 1 as my n value times 1. So this formula actually, if we just do 1 year and I simplify these values, I just get my original formula that we used in the last lesson, right? So that was this formula up here. Since I only have 1 year and it's compounded every year. Okay? So this is our example that we used in the last lesson, basically. And I'm going to calculate this. I got 800 times 1.03 to the first power. So that's just 1.03. And 800 times 1.03, if I do that on my calculator real quick, is 824. And this is dollars. Okay, so this is my formula from the other day or yesterday or whenever you watched the video. Okay, so now option 2, I have an interest rate compounded monthly. Okay, so monthly, I want to think about how many months are in 1 year, right? So we know there are 12 months in 1 year, so that means that my n value is going to be 12. Okay, so we already know that my p-value is 800, and then I have 1 plus my rate, now over 12 to the 12 times 1. So I'm substituting in my p, my r, my n, and my t, because my t is 1 year. Okay, now I'm going to calculate this value. So F equals 800 times 1 plus, I'm going to need to use my calculator again, so 0.03 divided by 12 is 0.0025 to the 12 times 1 is 12. Okay, so this plus 1, and I'm going to say this is to the 12th power because we know that exponent's going to go to the 12th power. Okay, so I got 800 times 1.0304. So when I multiply this by 800, I get $824.33. Okay, so that's kind of better, right? If we have an interest rate that's compounded monthly, I'm earning 33 cents more, which makes sense because I'm going through the interest a couple more times a year. All right, now option 3 is compounding continuously, which is the most amount of times we can compound in a year. Now the compound continuously formula is PERT, right? So F equals P e to the RT. Anytime we see continuously, we're going to use F equals P e to the RT. So we know my we know my P is 800. E is that value E, and my rate is still 0.3, and my time is 1. Okay, so this is new. In your calculator, there's a new button that we're going to use. It's that E to the X button. So I'm going to put in my exponent. So 0.03 times 1 is 0.03. And then I press the E to the X button. So I did the exponent first. Let me do that again. 0.03, and then I touch the E to the X button. Okay? So I get 800 times 1.03045, which is going to be, so if I multiply this by 800, I get $824.36. So what we've seen here, based on my 3 values, compounding at different intervals, right? So compounding yearly, I got $824. Compounding monthly, I got $824.33. But compounding continuously, I got $824.36. So anytime you see continuously, that means we're getting the most amount of money possible with the compounding periods. Okay? So obviously they should choose option 3, because this is going to make them the most money. Okay, so that's why it's important to know these other formulas and to know what compounding continuously can do. We're going to do one more example, and then you'll have practice to do in your on your own in the Google form. Okay, So this question says, Marcel deposits $3,000 into a retirement account that has a 6% interest rate that is compounded continuously. Write a formula to model how much money Marcel will have after each year and how much money will he have in 20 years. Okay, so right off the bat, we're using years, which is great because we know that anytime we're using compounding, our t needs to be in years, right? Now, we need to write a formula and figure out how much money he has in 20 years. Okay. And we know this is compounded continuously, so we know that the formula is going to be PE to the RT, or PERT. So let's take a look. What's my P value? P is going to be that initial value. So he deposits initially $3,000, Marcel. Then he's got an interest rate of 6%. So if it's a 6% interest, again, we're doing 6 divided by 100, which is 0.06 for the rate. So now I can substitute these values into my formula. So F equals 3,000 times e to the 0.06. And I'm going to leave t for now because they said write a formula first. So this is my formula. Now, if I want to figure out how much money he has in 20 years, I'm going to say, okay, t equals 20 years. And we always want to be in years when we're using PERT. Okay, so I can say F equals $3,000 times e to the 0.06 times 20. Okay, so I'm going to take out my calculator, and I'm going to do 0.06 times 20 is 1.2. So I have 3,000 times e to the 1.2. And then, I got these papers. I'm going to hit my e to the x button, and I get 3.332. So I get 3,000 times 3.32. So I'm going to multiply this by 3,000. And it looks like after 20 years, Marcel will have $9,960.35 in his retirement account. Okay? So, in 20 years, Marcel, who initially deposited $3,000 into his retirement account, since it's compounding continuously with an interest rate of 6%, now he has almost $10,000. And this is like a real thing, right? So people have these retirement accounts, and you want to get compounding continuously, and you want to have the highest interest rate possible because that's earning you money, right? So after 20 years, just sitting around doing nothing, now you've got almost $10,000. That's great. Okay, so you've got a Google form to do some practice with these problems. Please refer back to this video or text me if you need anything. All right, have a good day.